Alrighty guys, welcome back. So today what we're going to be looking at is corrections or a little bit of help from the midterm assessment. So we're just going to go through and go over the problems that were most commonly missed. So starting here with problem number 3, our instructions are to estimate the product. So if I'm going to be completely honest guys, I'm not a huge fan of this type of problem, simply because in the end we can just get out a calculator, multiply these two numbers, and there's no need for estimating. But it is something that we covered in chapter 1, so we will talk about it now. So whenever you're estimating a product, basically what they want you to do is use what is known as front-end rounding. You're going to round both of these numbers to their largest place value. So 87, you want to round that to the tens place, largest place value here, and 248, you want to round that to the hundredths place. All right, so notice that 87, this gets rounded up to 90, while 248 gets rounded down to 200. All right, so what we had was 87 times 248. Okay, and if we are going to estimate, we're going to front end round. This number here becomes 90 times 248 becomes 200. Okay, so the reason we do this, guys, is that we're able to now just multiply these two numbers that we see at the front of both of our numbers. 9 times 2. Well, we should know that 9 times 2 is 18. And then you can just count how many zeros you have. 1, 2, 3. And add that to your number at the end. So your final answer here is just going to be 18,000. So an estimation to this product, 87 times 248, is 18,000. All right, moving on to our next problem here. That was problem number 23. Come on, excuse me while this loads really quick. Here it goes. All right, so for problem number 23, we have 13 over 30 minus 34 over 75, and we are supposed to perform the operation. In other words, we need to subtract these two fractions. So the first word that should be popping into our head, or words I should say, are common denominator. We're going to have to get a common denominator here. So we have 13 over 30 minus 34 over 75. So we have 13 all over 30 minus 34 over 75. All right. So as I said earlier, guys, we're subtracting two fractions, which means that we're going to have to find a common denominator. So currently we have two different denominators. One is 30 and one is 75. We need to find the LCM, or the least common multiple, between these two numbers. So remember, you pick the largest of your denominators. In this case, it is 75. And we're going to go through the multiples of 75 until we find a number that is also a multiple of 30. All right, so you always want to check the largest number itself, 75. Maybe it is a multiple of 30, but we should see that it is not. All right, 30 times 2 would be 60, and 30 times 3 would be 90, neither of which are 75. So let's go ahead and take 75 and look at its next multiple, which would be to multiply it by 2. 75 times 2 is 150. All right, now 150 is in fact a multiple of 30. All right, because if we think about our factors of 3, which are similar to our factors of 30, just off by a factor of 10, all right, you have 3 or 30, 6 or 60, 9 or 90, 12 or 120, and then finally 15 or 150. So 150 is the least common multiple between these two denominators, which means that it is the common denominator. So how do we obtain 150 from these two numbers? Well, we're going to have to do a little bit of multiplication. All right, in particular, we're going to have to take our denominator of 30, and we are going to have to multiply this by how much? We would need to multiply 30 by 5 in order to get 150. All right, but remember that you don't want to change the value of your fraction here, so you have to also multiply your numerator by 5. And we're going to have to do the same thing with our other fraction, which is 34 all over 75. And once again, remember, we're trying to get our denominator to be 150. Well, we know that we would need to multiply 75 by 2 in order to get 150. Now, in order to not change the value of this fraction, we would also want to multiply our numerator by 2 as well. Pardon me, I should have carried my equal sign. So we're just saying that this difference meaning subtraction problem, 13 over 30 minus 34 over 75, this difference is equal to this difference here. Notice all you're doing is taking your two original fractions and multiplying them by the number 1. And when you multiply anything by 1, you're not changing the value of those numbers. So this subtraction problem is the exact same as this subtraction problem. So let's go ahead now and simplify our fractions, meaning we need to do some multiplication. First of all, we'll multiply our first two fractions here. Remember, when you're multiplying fractions, guys, we just want to multiply straight across. So we start off with 13 times 5. 13 times 5. And that is equal to 65. All over 30 times 5, we know that that is 150. Minus. Now we're going to multiply these two fractions. When you multiply fractions, we multiply straight across, numerator times numerator. 34 times 2. 34 times 2. That is 68. All divided by 75 times 2, that is 150. Okay, so we are now finally left with just two fractions to subtract, 65 over 150 minus 68 over 150, and they have a common denominator, meaning that we can now subtract these two fractions. So remember, when you actually perform the subtraction, we keep our common denominator of 150, and we only perform the operation of subtraction in our numerators. So we have 65 minus 68. So 65 minus 68. And notice here that we end up with a negative 3. Negative 3. All right, so this guy's here is an answer. Let's take a look if it asks. It just says to perform the operation, so I think that it might accept this as the answer, although I do want to point out that you can simplify this answer because your denominator 150 contains a factor of 3, which you see up in your numerator. So your numerator here, your numerator here is -3 all over. And 150 is the same thing as 3 times 50. All right, so notice you can think you have 3 divided by 3. Remember that 3 divided by 3 is 1. Another way to think about it is that these factors of 3, this 3 and this 3, those cancel each other out, and all you're left with are a 1 in both spots. You're left with 1s here and here. All right, do not forget this negative still applies. Okay, so our final answer then, excuse the noise there, completely simplified is going to be -1 all divided by 1 times 50. And 1 times 50 is just 50. So -1 over 50 would be your final answer. All right, hopefully I have a time for one more here. So let's take a look. Our next problem is number 15. And I think on this problem we might just be able to kind of talk through it. It says a readout from a testing device is shown below. So here's our testing device. Here's some data that was gathered here as this graph, this red line. It says use the number line to find the height of each of the peaks and the depth of each of the valleys. Enter your answer as comma-separated lists. So if we take a look here, guys, we're told that a peak is any time that we reach a maximum number and then come back down. And then a valley is whenever we reach a minimum and then come back up. Hopefully this is a little bit intuitive to most of us, and we think of this as a valley and these as peaks. So the first thing it asks us to do is find the peaks. So let's take a look at that. Well, we just want to follow our graph. All right, so starting down here, notice that we come up and now we come back down, meaning a peak has been created here, and that seems to be at 2. All right, so now we'll come back down from that peak, and we reach a valley there, and we come up, and this obviously is a peak as it's told to us as to be a peak, and that would occur at 4. We're looking for comma-separated lists, so you want to throw in a comma there. We'll come back down to another valley, back up to a peak. All right, notice here, guys, that this peak falls right in line with 0 here. All right, that might seem a little bit weird that a peak has a value of 0, but in this case it would. And then it comes back down to a valley, and then it comes up. So notice here, guys, that this line does not come up and then go back down, meaning that this here is not a peak, because we do not know what occurs outside of this device. For all we know, this line is going to continue to go up, meaning that this would not be a peak. So that would be your final value for your peaks. And now our valleys. Again, starting from the left, going to the right, we come up to our first peak, down, 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 and then we come back up, meaning we have a valley here. That would be at -3. We go up to our second peak and then come back down and then come back up, meaning we've created a second valley here at -5. And then we go up and down and back up. Once again, this one is explained to us to be a valley, and that would be at -1, -2. Okay, so these would be our peaks and valleys in comma-separated lists. One quick note, guys, I did have one student put in an answer where they had just thrown in another comma here in case there was another peak, and then they did not write another number afterward, but the problem was still counted incorrect even though her 3 numbers were correct. If you think this happened to you, please, please, please go in and check, and if this did in fact occur for you, I will happily change your score because you still listed all of the correct peaks or valleys. It's just for whatever reason the software will not count this as a correct score because of that extra comma. All right, so please go in and check if you think that may have happened to you. All right, These are the 3 questions I'll be able to get in this time, guys. There will be one more video coming. Stay tuned.